Hello there. Welcome to this podcast, one of two podcasts, looking at a whole Biology 2 foundation paper and just some pointers and some common mistakes you're all making on this paper and how to really get above that 35 mark value, because don't forget that's all we need out of 60 in order to get you that grade C. So, first thing to note is at the top of each question is a heading which gives you an indication of what question 1 is all about. So it's just use it as a bit of a focusing tool. So I know the rest of this question is all going to be about digestion and digesting food. Okay, so let's begin. Now the questions usually start easiest in terms of demand and get harder throughout this question. So we've got a picture of the digestive system here, and we've got words from a box to choose here. So during digestion, large molecules are broken down into small something molecules. So if we're not sure, go right, I don't really know that one, I'm going to move on. Proteins are large molecules that are broken down into, I can remember that, it's amino acids. So that's that one gone. So now we're back to this one. So then you do elimination. Well, lactic molecules doesn't make sense, because when Sirs talks about lactic, he's always said lactic acid. So it can't be that one. DNA molecules, nothing to do with digestion whatsoever. So it's actually out of these two. And if you're still struggling then, it is going to be a 50-50 guess for you, isn't it? But the actual answer is soluble. That means it dissolves. Okay? Molecules that are able to dissolve. Okay, turn over. Right, data question. So now we're on with a data question, and there's going to be many questions on this paper that require you to just look at data and interpret data, either a table or a graph, that won't necessarily draw on your scientific knowledge. It's looking at your analysis skills, and it's a calculate. So it's calculate the difference. So I'm doing a subtraction here for this question. So calculate the difference in mass of food digested by organ W and organ X. Right, okay, I'm just going to find a ruler. There's one here, look it. So, organ W, circle, and organ X, circle. So I'm after the difference. So I draw a line across. Right, so how many little squares are there within this one? It's up to 10. So there's 1, 2, 3, 4, 5 squares. 10 divided by 5 is 2. So each small square must be worth 2. So that means that is 8. And going across, see, I'm drawing on my paper. And this is actually in between, look. So that is in between 36 and 38, which of course everybody knows is 37. So X is 37, W is 8, sorry. So my sum is 37 minus 8. I'm going to write that there. That will get me 1 mark. Because if I then screw up on my calculator or my head, if I'm good at maths, then I'm not going to lose a mark. But the actual, obviously, the subtraction is, use your calculator, you might as well, you've got one. Okay? Is 29 grams. Okay, moving up. So now we're on a tick box activity. The food digested in organ Y was mainly carbohydrate. Complete the sentence by putting a cross in the box next to your answer. Organ Y is most likely to be B. Where, so the question is asking you, where is food digested ultimately? The food is digested in the small intestine. Okay. So now we're coming to the end of question 1. So these questions at the end of a question are always getting harder and harder and harder. So, state the role of peristalsis in the alimentary canal. Everybody came out and said, what's the alimentary canal? I haven't heard that before, I don't get that. But my question to you would then be, can you figure it out? Or can you answer the question without that? State the role of peristalsis. You should recognise this word. It's when the esophagus squeezes and contracts. So state the role of that. It's contraction of the esophagus, pushing food down from the mouth to the stomach. Okay, that's more than one mark that you needed. Okay, I mean the mark schemes just have to moves food. Okay, but that's a textbook answer, so it does no harm in knowing that. The point is, don't be fooled by that. Okay, you should have known what peristalsis was anyway. So then it is a little bit tricky. So describe how digested food molecules move from the alimentary canal to the heart. So this is just asking you, so once food has been digested in the small intestine, how does it get to the heart? That's what this question is asking you. So food is absorbed or diffuses into the bloodstream and goes to the heart in veins, because blood goes back to the heart and veins and away from the heart and arteries. But granted, that is a tough question, okay? But you should always picking one up. But if you think about it, if you really analyse this, if you drop the last 2 marks out of the question, you're still going to be in the right ballpark. Okay? Because the marks previous on this side, you should be picking up. Right, let's turn over. This question, cell division. So this whole question, question 2, is cell division. Mitosis. So straight away you should be thinking, right, do I know what mitosis is? And more than likely, the question is going to be about the difference between that and meiosis. In fact, it is. Describe how the diagram shows that this cell division is mitosis. So why is this mitosis and not meiosis? Well, you've got one cell division, so it splits up once. Yeah, so what? Because meiosis has 2 divisions. You've got 2 daughter cells that are identical to parents, and they're diploid. Okay, so you've got 4 marks there to go at. It's after 2. Okay, so then you construct your sentence around that, but that should be a trigger. You should be approaching that question thinking, I know the difference between mitosis and meiosis. It's around these things. And the examiner is after 2 of these. Right. You can just, because there is one cell division that produces 2 identical diploid daughter cells. So I've incorporated a lot of marks into one sentence there, and I'm not saying you would, but the point is there's 4 to go at, and you've got to mention 2. So I've gone 1 cell division, there's 1 mark, 2 identical diploid daughter cells. So I've written 3 marks with 2 marks there. Okay, right then. A lot of people had a go at this, but got the final answer wrong, which is frustrating. So most of you picked 1 more mark up on this, so that isn't too bad. But let's try and strive for getting 4 marks. It's a very simple sum to the ones you have to do for half-life at P2. So let's have a little read then. A skin cell divides by mitosis once every day to produce new skin cells. Calculate how many days it would take to produce 16 skin cells. And a lot of you drew a diagram from 1. So 1 skin cell, day number 1, goes from 1 to 2. Day number 2, it goes from 2, that one's going to go to 2, that one's going to go to 2. In total, if you count these up, you've got 4. We're not after 4, we're after 16. So I'm going to stop the drawing there, so it's doubling every day. So 3 day, I'm going to go 4 to 8. And then on the 4th day, I'm going to go to 8 to 16. The actual answer is 4 days. 4 days time, I'm going to have 16. Okay? Turn over. So we're getting trickier and trickier all the time now. So, cloning mammals involves mitosis. This is a hard question, don't get me wrong. Okay? Describe one advantage and one disadvantage of cloning mammals. So after one advantage and one disadvantage of cloning mammals. So, you can produce animals that have a desirable feature. Now, we talked about this, and you should have talked about this when you're talking about in agriculture and farming. Okay, if you've got a prize-winning bull that's amazing at producing, or amazing stud that produces lots of meat or produces lots of great offspring, then that is beneficial for that farmer to have lots of those bulls or lots of those cows that produce gallons of milk. So you can produce animals that have a desirable feature. Also, a lot of you put as well, some of you put this, conservation of a species. Okay, so there's two there, but it's just after one. Okay, so they're really two go-tos for that question. However, the disadvantage, always think about health. There are always health issues with clones. That would have got you the mark. Also, shorter lifespans. So I've given you 4 possible answers, you only need the 2. One advantage, one disadvantage. And lastly then, the last part of this question on cell division is looking at meiosis. So, meiosis. Use the words from the box to complete the sentences. Meiosis is used in sexual reproduction to produce, again, look at the boxes, odd one out time. If you do not know, you can eliminate some. For instance, meiosis is used in sexual reproduction to produce 2. That does not make sense. It cannot be that. 4. It cannot be that. To produce double. Unlikely to be that. So you are ultimately choosing between 2 here, aren't you? If you've forgotten, you're just going to have to take a punt. But hopefully you remember that gametes is the word for sex cells. So gametes is the one that goes down. You can put a definite cross so that you've used it. So how many cells does it produce? This word might have thrown you, which just means half the number of chromosomes. But you can get rid of that word and it still makes sense. Meiosis produces how many cells? So meiosis goes 1 to 2 and then once more, so it's the same as mitosis to that point. Well, sort of anyway. And then you've got half the genetic information, so you've got your haploid and you've got 4 gametes, so these are sperm cells or egg cells depending on where you're at, male or female. So it's 4. Okay. Right, the last question we're going to do this on this podcast, and it's all about the Olympic training. So although this isn't giving you an actual guide as to what question it's asking you about, you should be able to figure out. I'm going to be talking here about respiration, because we're running, okay, we're moving, and respiration energy is going to be a key player. Lactic acid, aerobic, anaerobic. Okay, let's read. Athlete training and running machine. The mass used where he measures the volume of oxygen she uses per minute. The athlete runs faster in a race than when she is in training. Explain why running faster changes the volume of oxygen per minute. So when you're running, why do you need more oxygen? That is what it's asking you. Okay? So, it's 2 marks again. So when we run, there is a higher demand for energy. So when we run, we're going to use more energy. So when we run, there's a high demand for energy. Therefore, we need more oxygen. So more respiration can take place releasing more energy. Okay, so I've got loads of marks there, but a lot of you said more oxygen. I'd be amazed if any of you didn't get 1 mark for that question. You all said more oxygen, but why? Why do you need more oxygen? You need more oxygen so more respiration can take place. You can't have one without the other. They are linked, and then obviously that's then linked with energy. So when you're answering questions on this, you've got to keep those 3 in mind. More oxygen, more respiration, more energy. Bang, bang, bang. Okay, they're only after 2. There's 3. You should always give when you're answering these questions. Describe how walking. Now, again, all of you got this. Well, all of you got 1 mark at least. We're describing the graph, and all of you recognise that I've got to say how this affects this, and off you went and did that. So you said, as walking speed increases, oxygen used also increases. And you did the full stop. There. Done. It's not done though, because you're only getting 1 mark for that. If you're describing graphs, how many times have I told you? You must quote some data. Okay? And look at the mark scheme here. Correct reference to data from graphs. So any numbers would have done. And you can pick up that 2nd mark. All of you have got that one. Done. But none of you, or very few of you, have got that one. I think it was 1 person that got something on there. So let's just mention something. So, for instance, here, there's an increase in oxygen, because it's quite steady here, and it goes, doot. Okay, there's a change there. So I'm just going to mention that. So, however, after 8 kilometers per hour, oxygen is used faster. Okay, something along those lines. You could have picked any number. You could go from there as a change as well. Okay, or you could say for the first 6 kilometers per hour, the oxygen used goes at a steady rate. But you've got to use some kind of data. Explain why this Olympic water did not get cramp in their muscles. What is cramp? Cramp is lactic acid. Where does lactic acid come from? Lactic acid comes from anaerobic respiration. Okay? And when do you use anaerobic respiration? High intensity. And there are your 3 marking points there. So they haven't got cramp walking at 4 kilometers an hour because the intensity is low, so the athlete will be respiring aerobically. Cramp occurs when anaerobic respiration takes place because of lactic acid. Okay, so that is basically it. Done. A lot of you just got no marks on that one. You've got to make that link when there's enough oxygen around. I suppose to just put the belt and brace on it, say oxygen supply was I don't know, sufficient. Okay, a lot of you got no marks on that. Some of you recognise cramp, but cramp is lactic acid. Remember when we did this with the fingers? Okay, high intensity, you get cramp. It's because of the lactic acid. Okay, lastly, just running quickly because I'm running out of time on my clock here. Okay, a lot of you have spelled out that correctly. CO2. Oxygen moves from the blood into the cells. When we're talking about things moving, the answer could be 2 things: diffusion or osmosis. Osmosis is only linked to water. That is it. This doesn't mention water, it's mentioning oxygen. Therefore, it's got to be diffusion. And lastly, this is you're needing to know your cardiac output equation here, and that is heart rate stroke volume is multiplied by heart rate times stroke volume. So you've got to recognise it's heart rate per minute. But again, if you're struggling there, it is a guess for 1 mark. Do not leave them empty. Okay, so that is 3 questions of 6 done. I'm going to do the other 3 on a different podcast. For now, goodbye, toodaloos.